Hello everyone, and welcome to the first video of this week's topic on interfaces and abstract data types. We're going to start this week off by talking about interfaces, and we'll start even right away with creating a pretty simple interface to get going. An interface is kind of like a job posting. It's going to list things like the responsibilities, but it doesn't actually tell you how the person will do the job. In Java, an interface is literally this same idea. It describes what must be done, not how it's done. We list the behaviors, the methods, not the implementation. And today we're going to unpack that. Let's start with the simplest possible interface. I'm going to just get my main class up over here, as I like to do in my programs. And as usual, I put everything in one file just to make it easier for viewing here. Here is a tiny example of an interface in Java. Interface, new keyword interface, greeter. Define that behavior, greet. Actually, lowercase typically for our methods. There we go, and I'll save that. This is a contract called greeter. It says any class that's going to claim to be a greeter must have a method that's called greet, and that method takes in a string, and that method returns nothing. Now, notice what's missing here. There is no method body. In fact, we have a semicolon at the end of the signature. There's no curly braces, there's no code inside, it's just the signature. And that's because in Java, interfaces are about what methods exist and what their parameters are and their return types. They are not about how those methods are implemented. There's also one more important rule. There are no instance fields in an interface. You cannot store per object data in an interface. You can't do something like int count here, the way you would if this was a class. This is different. No per object data. Interfaces are all about behavior. They're not about object state. And so if an interface is a job posting, who actually is going to do the job itself? Well, that's where our classes come in. In order to actually fulfill this contract, we need to do something like a console greeter. And a console greeter is going to implement that interface. One more keyword here for you, implements. Anytime you want to implement an interface, we use the keyword implements. Now in here, what we need to do is we need to actually define that method greet. String name. And then we can say system.out.println, hello, name. All right, this class is saying I am a greeter, using the code right there. I promise to provide a greet method that matches the contract. You'll notice void greet and a single string, void greet and a single string. This name does not have to be the same. Variable names, as we know, can be different. But it is important that there's a single parameter of type string. In order to run this, I guess even before I run this code, let's just compile it so that we can see what happens here. All right, let's go to my desktop and let's compile my .java file, and we'll see it compiles no problem. What happens if I break the contract that greeter is expecting? What if instead of greet, I say greet me by name? Oops. And let's try to compile that code. As we can see, the compiler is going to complain. This class, console greeter, is not abstract and does not override the abstract method greet in greeter. What it's basically saying is we need to enforce the contract of this interface. We must we must implement every method in the interface, not just some of them, all of them. So if there are more methods in here, they would all have to be implemented over here. Let's put this back like this. That's the core behavior. Interfaces declare the requirement up here using that keyword interface and a bunch of method signatures. And classes will use this term implements to fulfill those requirements. Now, there is one other thing you can put inside an interface, and it does sometimes surprise people. So since we're looking at how do we actually implement an interface right now rather than using it, just define and implement it, let's look at that additional ability of interfaces. Interfaces can contain constants, as in values that never change. For example, whoops, wrong place. String app name equals main. That's the name of my whole program, right? In Java, anything you put in here, as in any sort of properties you put inside your interface, is automatically considered public, static, final. Even if you don't write those words, it is implicit, public, static, final. Implicit. So here our app name is going to be public, meaning it is accessible from anywhere. It will be static, meaning it belongs to the interface, not to an object. And final, it cannot be changed, which is why we're going to follow our programming standards of all capital case. We can even read it exactly as you would expect to. Greeter.appName. Just like any static variable in any class that we've done before. We can't reassign it, but this will actually run and print out main. As expected, it will go and grab this one. Now, I will say that I recommend using constants in interfaces pretty sparingly. There aren't a ton of reasons why we would need one, and definitely not at this level, but it's still really good to know that they exist. So why do we bother with interfaces at all, and what problem do these help us solve? Interfaces give us the power to code to behavior instead of coding to specific classes. If I now write code that depends on the greeter interface, I don't really care if it's going to be printing to console or maybe printing somewhere else. All I care about is that greet exists in those functions. For example, let me show you another implementation of the interface. Class excited greeter implements greeter. We once again will need to bring in this function here. Welcome. We're going to do name. There we go. I am so excited you are here. Same interface, greeter, greeter. Same method name, greet, greet, greet. And same parameter type, string message, whatever, string name, string, same type. But we can see the behavior is actually different, right? Here we're just saying hello, and here we're going to say, I'm so excited that you're here. If my program just knows it has a greeter, it can plug in either implementation without actually having to change the code that is using it. And this is the beginning of the idea of decoupling, keeping our pieces of code separate. It makes things like testing easier and swapping behavior easier. It also can really help us understand our code, to be honest. So let's see this swap in action. Previously, I had just tested this out. I'm going to delete it for just a minute. Now, we have this greeter variable here. We'll just say GRT. And right here, we can say new console greeter. You'll notice that on this side of the declaration, I can say it's an interface. On this side, I have to put the actual class that implements the greeter method. That's by design and intentional, and we'll learn a bit more about that later on. If I now go on to say greet, and I pass in Anjali, as we'd expect, oh, what did I do here? Oh, I put the word name down here. Message, see, there we go. We can see that it prints out hello Anjali. Now I can go and I can actually change what that variable is pointing at. GRT equals new excited greeter. And once again, I can greet Anjali over here. Just clear this up. And we can see that without making a new variable, I can reuse the same one for two different implementations, right? They're both the same variable type, which is greeter right here, same variable type. Two different classes coming out behind it, console greeter and excited greeter. That makes us have two different outputs. This is the start of the power of treating interfaces as contracts that multiple classes can fulfill. So today we saw that an interface is a contract, and we're defining method signatures only. Let's write some notes down. Interfaces. It is a contract. Method interfaces, method signatures only. Make some more space here. We also learned that in order to implement this contract, a class uses the, I don't know why it's all capital. A class uses the keyword implements to promise it will provide all the methods in the interface. Oh, that should have been apparently a multi-line one. It's a bit long there. There we go. Perfect. We also learned that interfaces can contain constants, but not instance fields, which is why we named it all uppercase, follow standards. And we learned that multiple classes can implement the same interface and provide different behavior. Oh, did it again, hey? There we go. Lots for the very first time that we've ever seen an interface. In my next video, we're going to lean into this last point right here about multiple classes, and we're really going to show off how we can use interfaces as types. And that's going to lead us straight into this idea of polymorphism. Thanks, everyone, and I'll see you there.